This is Daniel Coosbury, and we are still working with integers. We're about to start multiplying and dividing. But before we do, let's talk about what is going to happen when we multiply numbers with different signs. So here's a mnemonic that I really appreciate, and it kind of tells you what to do when you're multiplying a positive number and a positive number. You end up with a positive number. And when you multiply a positive number and a negative number, you end up with something negative. If you multiply a positive and a negative over here, you end up with something negative. And if you do a negative times a negative, you end up with a positive. So you end up with some sort of chart like this that should tell you what to do. It's not a terribly hard thing to do, but what I would do, I would maybe jot this down somewhere. The nutshell version of this is when you multiply numbers of the same sign, you end up with positive number. So positive times positive gives you positive. Or negative times negative gives you positive. When you multiply numbers with a different signs like positive, negative, you end up with a negative number. Or negative times positive, you end up with something negative. This mnemonic is a really nice summary of how multiplication works. So in a nutshell, when we multiply numbers, we're going to multiply them as usual. So in example 7a, we'll do 4 times 21 to give us 84. But since this is a positive times a negative, we'll look, okay, positive times a negative. That gives us a negative 84. So different signs will give us a negative number. B, we can do 3 times 5 is 15. And since these signs are the same, negative times negative, we end up with a positive answer. So negative 3 times negative 5 is positive 15. Here we have negative 12 times 0. Well, 12 times 0 is 0, and 0 is not really positive or negative, so we'll just leave it like that. Here we have 3 numbers we're multiplying. They're all negative, so maybe we can just do this one step at a time. Why don't we multiply these two first? We got negative 3 times negative 10 will give us a positive 30. Same sign, so they end up being positive. And then we'll multiply it by this negative 2 since we haven't done that yet. So positive 30 times a negative 2 gives us a negative 60 since those signs are different. So in this case, now we have 3 negative signs multiplied together. We end up with a negative at the end of the day. So 2 of them would cancel out, give us a positive. That third one ends up making this negative again. Okay, here we have 3 numbers, and we can kind of do what we did last time. Let's just multiply 2 of them together just to do it. So negative 2 times 3 would give us negative 6, and then we need to multiply that by the negative 5 since we haven't touched it yet. Negative 6 times negative 5, it gives me a positive 30. So multiplication with integers doesn't turn out to be too bad because these rules just work. So multiplying with the same sign gives you a positive, and multiplying with different signs gives you a negative. Otherwise, multiplication is just multiplication. So now we should talk about exponents. Exponents is just a way of multiplying numbers by themselves and maybe writing that in a nice way. So whenever you see something squared, for example, this little number we can say is a square. This really just means we're multiplying this big number, negative 5, times itself for a grand total of 2 times. So I can rewrite this negative 5 squared as negative 5 times itself, which is itself is negative 5. I'm multiplying its negative 5 times itself for a grand total of 2 times. So negative 5 squared is just negative 5 times negative 5, and that gives me a positive 25. Negative times a negative is a positive. So that's how we would interpret that squared. Okay, this one we got to interpret a little bit different because we have a negative and then a 5 squared. We actually want to think of this 5 squared as a number in itself that's about to become negative. So we have to interpret this as negative and then 5 squared, or 5 times itself. So 5 times 5. Notice it's a little bit different than the one before it because we're not putting negatives in here. This is just 5 times itself, and then we're going to end up making it negative. So 5 times 5 is 25, but then we're going to make that negative because that negative sign's out there. So notice how these are written differently. Here the negative sign's inside the parentheses, here it's outside the parentheses, and you end up with different answers because of that. So that's something you might want to keep your eye on. Okay, here's an exponent. There's a 3 in here. We can say that's to the third power, negative 10 to the third power, or we could say it's cubed. It's another word like that. What this means is we're going to multiply negative 10 times itself for a grand total of 3 times. So let's go ahead and write out negative 10 times negative 10 times negative 10. So that's what we're doing, negative 10 to the third power. And if we do the multiplication, negative 10 times negative 10 is, I'll just do that first, is positive 100. And then this negative 10 we haven't touched yet. It needs to be multiplied in. So positive 100 times negative 10 gives me negative 1,000. So that's the answer to that. So when you see this exponent, if it's not clear what to do, this is multiplying this number times itself for a grand total of 3 times. So 1, 2, 3 times. So I can do the same thing here. I got negative 2 to the 4th power, and we don't really have a fancy word for that. That's just to the 4th power. So this means I'm multiplying negative 2 times itself for a grand total of 4 times. Sorry, my pen's not quite working well. So negative 2 times negative 2 times negative 2 times negative 2. And I'll do that multiplication. So negative 2 times negative 2 is 4 times negative 2 times negative 2. So if I do that multiplication, I get negative 8 times negative 2. And then I'll do that multiplication, I get negative 8 times negative 2 is positive 16. So notice in that case, I'm multiplying 4 negative numbers, and they end up canceling out to a positive answer. So that's how I would work with those exponents. Division is nice. Division, we can actually use the same mnemonic we had last time. So if I multiply positive numbers and negative numbers together, let me see if I can change the colors here. Positive times positive is positive, negative times negative is positive, and these two opposite signs end up being negative. Division works exactly like division is supposed to work. You just got to keep the signs in mind. So 100 divided by 4, or negative 4, would normally be 25, but since you're doing a positive divided by a negative, that would have to be a negative 25. B is division as usual. 24 divided by 6 would give me positive 4. Nothing special there because there's no negative signs. Here we have same signs. Negative 10 divided by negative 2 would give me a positive 5 since those signs are the same. D, we have 0 divided by 24, and 0 divided by anything just gives you 0, so nothing special going on there. And then E, we have the weird one. I don't know if you remember from math classes past, but you can't divide by 0. So we can do 0 divided by 24 and end up getting 0, but we can't do 24 divided by 0. We can't ever have 0 at the bottom of this division. So kind of how we would write this, it's not a number. We would say this is undefined. Undefined, and leave that at that. So there's no answer to that. It's not a defined number. It's not real. So now that we've done all this, we can talk about order of operations. So we've done some multiplication, division, exponents, and all this stuff. Order of operations come into play with some longer math problems, and there's a nice mnemonic for the order we do things in. It ends up being PEMDAS, and I like thinking, please excuse my dear Aunt Sally. So here's this. What that means is we're going to tackle anything in parentheses first, and then we're going to tackle any sort of exponents we see, and then we'll do multiplication and division, and it kind of depends which one to do first. It's not exactly multiplication always first or division always first, but we actually tackle these about the same time. My side note is we'll perform these from left to right, and I'll show you what I mean by that. But just because we put M in front of D doesn't mean that there won't be a case where we divide first. Think of this as kind of a group. So parentheses first, then exponents, then multiplication and division, whichever you need to do first, and then addition and subtraction, whichever one comes first. So from left to right. If you see subtraction on the left first, then do the subtraction first and then the right. Let me show you what I mean on these examples. Okay, so here we have some stuff going on. I see parentheses that suggest I'm going to multiply here, and I see addition. So according to please excuse my dear Aunt Sally, the PEMDAS, I should multiply and divide before I add and subtract. So here I see multiplication, which I want to do before I do that addition. So let me go ahead and rewrite that negative 5 because I'm not adding it. And then I'll do negative 3 times 8, which will give me negative 24. So now I want to add those two numbers together. So negative 5 plus negative 24, they're two numbers of the same sign, so I'll add the numbers and put the negative sign in front of it. That's 24 plus 5 with a negative sign, negative 29. And maybe I should put equal signs here for a good measure, just so you know what I'm doing. So that's how we would apply order of operations to that one. So this next one, I see some exponents in here, and I want to use my order of operations well. So here I see exponent, which should happen pretty early, and then I see some multiplication here and here, and then I subtract. So I should do things in that order. Let's tackle the exponents, then the multiplication, then the subtraction, which is down here at the end. So first we'll do, let's rewrite that 5 because we don't want to touch it yet. -3 times -3 gives me a positive 9, so that's what that exponent is. And then I'm not touching the subtraction yet. I'm not doing anything with this 2 yet, but I do want to do -2 times -2 times -2, and maybe, I don't think we've done that one yet, so maybe I'm just kind of jot this down over here. So this is -2 to the third. So -2 times -2 times -2 is 4 times -2, or -8. That's what that is. Let me put that over here. So tackle the exponents first. Okay, so now I have a problem that has multiplication here, here, and I have subtraction here. I want to do subtraction last, so let's not touch that. We can do the multiplication. 5 times 9 is 45. Subtract. And then 2 times -8 is -16. So we'll do that. So now I have a problem where we subtract. So we'll do 48 minus -16. If you remember how we subtracted integers, we'll just change that to a plus positive 16. So 45 plus 16 will give me 61. And that's that. So with order of operations, you kind of got to take these problems slow because you really only want to do one step at a time if you can get away with it, so that you don't lose something. In this case, if we had subtracted first, we wouldn't have got a number anywhere close to 61. So watch out for that. So this last example is pretty involved. It's just got several things going on. I see things like exponents and division and multiplication and subtraction, all these things. So we're really going to need to lean heavily on PEMDAS. Please excuse my dear Aunt Sally. And let's start out with the exponents because that's the first thing. I don't see any parentheses. So I'm going to tackle these, and I'm just going to rewrite everything that I haven't underlined because I'm not doing that yet. So 8 squared is 64, so that's the first thing. And then I'm not touching the 16 yet, I'm not dividing yet. And then 2 squared is 4, so that's going to go here. And then I'm not multiplying yet, I'm not touching this 4 or subtracting or doing the 3. So notice I'm just bringing everything else down except for that 8 squared, which I put there, and the 2 squared, which I put there. I'm doing the exponents first, so I did that. And then I see multiplication and division. So notice here there's some division, here there's some multiplication. And remember, in PEMDAS it gets a little confusing because we put the M before the D, but really we want to do whichever one comes first. So we kind of tackle these at the same time. I see division first, and then multiplication. That is, division's further left. So if you read from left to right, you see the division, and then multiplication, it's first. So we're going to do that, and then we'll do the multiplication in just a minute. So I'm going to bring down things that aren't having to do with that division, like the 64 and the minus sign, and then I'll do 16 divided by 4, which gives me 4, and then there's the multiplication sign, 4 minus 3. I haven't done any of that yet. So all I did here was I did the 16 divided by 4, and now I can tackle this multiplication. That's the next thing I need to do, and I'll bring everything else down that has nothing to do with the multiplication, like the 64 and the minus sign, and then I'll do 4 times 4, which is 16, and then I'll bring the -3 down because I'm not ready to do subtraction. So what I've done now is I've done the exponents, I've done the division, I've done the multiplication, and I can move on to adding and subtracting. All there is to do is subtracting, and let's keep that rule of thumb. Let's start from the left and then go to the right. So that means I'm going to do the 64 minus 16 first, and then I'll do the -3. So if I do 64 minus 16, that gives me 48, and then I'll bring down the -3, and 48 minus 3 is 45. So that is how I would tackle such a long problem like part C. Is notice what I did is I didn't try to do all this in my head or do just 1 or 2 like lines. I just wrote down 1, 2, 3, 4 lines, until I got it done, doing one step at a time, following that order of operations so that nothing uh, went wrong. So that's how I would recommend getting these done, and hopefully it'll go well. We're going to lean heavily on "Please excuse my dear Aunt Sally," and that should help with these really messy ones. So